We're back with 8.4 notes. Today we're going to be simplifying and solving quadratic equations with radicals. This is one of my favorite topics to teach. I think that it's really easy. It's the same procedure every time. So I'm going to give you a chance to write what you see, and we'll talk about the fun way and the rules of dating to simplify radicals. All right, so if you already have all of that written down, let's go ahead and jump in. For 72, square root, here's what we're going to do. We're going to make a factor tree starting with our smallest numbers. So the first thing we're going to try is a 2. Does 2 divide out of 72? Yes, it's an even number. So we're going to do 2 times what? 36. 2 is done, and we're going to line up our numbers by doing the same thing every time. So does 2 go into 36? Yes. We're multiplying 2 times 18. Check again. Does 2 go into 18? Yes. 2 times 9. Going to keep splitting until 2 won't work anymore. So does 2 go into 9? No. Let's try the next number. Does 3 go into 9? Yes. 3 times 3. Right now, if we look at this number, we're going to ask ourselves, can I factor that number anymore? No. 3 is done being factored. 3 is prime. So we know that we can stop. If I look at my next step, here's what we're going to think about. We're going to think about when you were in high school and your dad started teaching you the rules of dating, at least for me. The rule was the boys that you dated had to be the same age. You didn't want to date the younger boys, and we weren't allowed to date the older boys. So here's what happened. To make a date, you have to be the same age. Also, a date was 2 people. You were not allowed to bring your best friend on your date. So if I look at this, I notice that these 2's right here can make a date. 36, 18, and 9 all got broken, so we're not looking at them for the dates. Do you see any other pair that are the same age that could go on a date? Could we take the 2 and the 3? No, they're not the same age. Could we take this 2 and circle all of them at the same time? No, 3 numbers can't make a date. So that leaves us with a pair of 2's and a pair of 3's. Those are my dates. This guy right here, he's single. Okay, so that number is not have a date, does not have a partner. So when we go ahead and we start writing them out, we're going to think of this square root as a house. We're going to say, all right, where do my dates want to go? Well, if I was a date, I would want to leave the house. So that 2, that date of 2's is going outside. Same thing with this set of 3's. These 3's are going to go on the outside. Now, it's not 23, it's 2 times 3. All right, and this last little single guy, he didn't have anybody to date, so this single guy is staying in the house. He's in here. Last step is we're going to say we're multiplying what's outside, so 2 times 3 makes 6. Multiply the singles that are inside the house, well, there's only 1, so we bring down our 2. This right here is a final answer. Okay, take a second, write what you need. If you need to listen to that talk through one more time, go ahead. We're going to move on to the examples. All right, so the first thing that I'm going to do is I'm going to make a factor tree for each of these questions. Okay, so starting with 45. Can 2 go into 45? No. Can 3? Yes, 3 times 15. At this point, I don't have to check the 2's anymore, because if 2 would have divided out at the beginning, we would have taken all the 2's out before we got to 3. So we're staying with 3's until 3 doesn't work. So does 3 go into 15? Yes. 3 times 5. Does 5 split? No. 5's prime, so we stop. Let's try 48. Does 2 go into 48? Yes. 2 and 24. Does 2 go into 24? Yes. 2 and 12. Does 2 go into 12? Yes. 2 times 6. Does 2 go into 6? Yes. 2 times 3. 3 is prime, so we stop. Notice all the 2's should come first, then all the 3's. We might get to 5. We might get to a 7 or even an 11. Just depends on how far we get. Okay? All right, let's talk about this one. So 2 and 60. 2 and 30. I'm going 2's over and over. 2 times 15. But 2's don't work anymore, so I go to 3's. 3 and 5. 5 is done. I don't have to go any farther. All right. Remember also that all these numbers, once they get split, we ignore them. They're not there anymore. Okay, all we're worried about are the prime baby number factors that we got at the bottom. Those are going to make up our dates. All right, so we're going to do one more. We're looking at 2 times 49. 3 doesn't go into 49. 5 doesn't go into 49. So my next prime number is 7. 7 times 7. And since those are both prime numbers, we get to stop. Okay, let's go through. I'm going to use blue for dates and pink for singles. So if I circle up my dates, I have a blue pair of dates here, and I have one single. If I go to my next pair, I have one date, I have 2 dates, and then I have this extra single here. Okay, and this next one, I have a date of 2s. And then I have 3 singles on this one. I have a 2, I have a 3, and I have a 5. They are not the same age. They cannot make a date. It's okay to have a lot of singles. It's okay to have a lot of dates or even no dates. Okay? Number 4, I have one single little 2 right here, and then I have a date of 7s. So, what do we do with dates? Well, dates go on the outside of my square root house. Singles go on the inside, so 5. That's actually a final answer. There's nothing left to multiply, so he's done. Go ahead and draw a couple square root houses. All right, so my dates on number 2 is I have a date of 2s and another date of 2s. I have one single 3 right here, which means that my final answer, when I multiply, 2 times 2 makes 4. So 4 square root of 3. For number 3, I only have one date of 2s, but I have 3 singles, so 2 and 3 and 5. 2 times 3 times 5 is like 2 times 3 makes 6. 6 times 5 makes 30. So I'm going to have 2 square root of 30. That's my final answer. Okay. Last one, number 4. I have a date of 7s and one single 2. Which means that that right there is my final answer. Okay? If you need to listen through that talked out one more time, that's fine. 5, 6, 7, and 8, we're going to go through one whole problem at a time. That way you can see the full process. Okay? All right, so number 5. We're breaking out 21 first. We're going to factor it. 2 doesn't go in, but we do have 3 and 7. When I look at that, I can't factor it any farther. All I have left are 2 single numbers, which means that there's nothing I can do with that. There's no dates. Everybody's still single. So if I put it right back in, 3 times 7 would make 21. That's a final answer. There's nothing I can do with it. Okay. Number 6 looks a little bit weird because we've got this little extra guy hanging out on the outside. Let me show you what we do with him. Okay, so let's start it. 2 and 22. 2 and 11, and if you didn't know, 11 is prime, so we can't break apart 11 anymore, okay? These 2's make a date, just like we said before. This 11 makes a single, and this 5 actually here, he is an extra date, okay? He's already on the outside of the house, so we're going to treat him like an extra date on the outside, which means we have 5 and 2 on the outside, we have this 11 on the inside, and our final answer is going to be 10 square root of 11. Okay, we're going to do the same thing for number 7. First thing we're going to break apart is 2 doesn't go into 75, but 3 and 25, 5 and 5. So again, we have a date of 5s, and there's already that one date on the outside. We keep our square root house, and we had one little single 2 left in here. So this one's going to come out to be 10 on the outside. We multiplied 10 square root of 3. We got one last one. This is kind of a big number, so stay with me. We're going to test 2. 2 dividing out of that leaves me 98. 2 again leaves me 49, and we actually just did 49 up here, right? 7 and 7. So here's what happens when you see something like this. I have a date of 2's, a date of 7's. Do you see any singles left? No. And the reason for that is this happens to be a perfect square. So all I have to do is multiply these guys, and my final answer is 14. There is no square root symbol at all in this problem, okay? If If you need to watch any of that again, go ahead. Otherwise, we're going to connect this to the solving by square roots that we did before. Meet me on the back page. All right, so we're going through the full process now. I'm going to change colors. Here's what this looks like. You're going to be doing the same process as 8.3, but now if you get a radical, we're not going to be able to just say plus or minus 5. We're going to have to simplify the radical and say something like plus or minus 10 square root 3. Okay, so you're going to have to simplify before the answer. Let's look at that. We're subtracting 8 from both sides because we're trying to solve for x. X squared equals 20. Just like before, we're going to square root both sides. But right now, 20 is not a perfect square. So we're going to pull that same idea back out. We're going to do 2 and 10, 2 and 5. We're going to circle up our dates and note our singles. Now we can write a final answer. So we still have our x equals, we still have our plus or minus, but now when it comes to our answer, it's going to have a date of 2's, our square root sign, and our single still in here. That's a full answer right here. So the process looks the same, but when you square root, because it's not a whole number, we have to simplify, do our factor tree, get our dates and our singles pulled out, then we can write an answer. Okay? Let's try number 2. I don't have anything to add or subtract, so I'm going to divide by -6. We're looking at x squared equals, let's see, 35. If I go ahead and I try to square root this guy, sorry about that, that's a 45. There we go. All right, so we're going to square root this. Now, 45 is not a perfect square again, so let's break it up. 2 doesn't go in, but we can do 3 and 15, 3 and 5, which means we have one date and one single. So when I write my final answer, I'm saying x equals plus or minus, keeping my square root symbol, and then I can write my dates on the outside, that was my 3, and my single on the inside, that was 5. There's our final answer. Okay. All right, number 3, we're adding 4 to both sides to cancel it out. X squared equals 128. I need to square root both sides. So if you want to kind of think about it already, we're looking at x equals plus or minus, but we know we have to factor to get there. So I'm going to make my factor tree. 2 and 64, 2 and 32, 2 and 16. Ooh, we might need some more space on this guy. We got 2 and 8, 2 and 4, yikes, that's okay, and 2 and 2. All right, we got all kinds of dates going on. Let's see how many we got. We got 1, 2, 3, and this one little single down here. All right, so I'm gonna kind of rearrange this real quick. All right, so let's see how I can write this instead. All right, so we have 1, 2, 3 dates on the outside, and one single 2 on the inside. That's what it's looking like, okay? So if I do 2 times 2 is 4, times 2 again makes 8. So now I'm going to write my total. 8, nothing to multiply on the inside, but 2 is my square root. Okay, so x equals plus or minus 8 square root 2. And sometimes they're long and sometimes you got to rearrange your space. That's okay. Make sure you're showing your work. Squeeze it in there. Okay. Problem number 4. We have a little bit more work going on here. We're going to add 4 to both sides. I have 7x squared equals a negative 21. We're going to divide by 7. X squared equals a negative 3. And when I square root both sides, what's our rule right here? Because remember, we can't square root a negative. So what do we put? We would say x is non-real answers. Okay. All right, we are not going to do all of these. Let's jump and let's do 5. All right, so number 5, if I go ahead and cancel that 5, I'm subtracting 5 from both sides. Negative x squared equals a negative 9. I need to divide out that negative that's in front of both of those. Gives me x squared equals a positive 9. Now I'm ready to square root to get rid of that x squared. In case you're thinking, yeah, 9 square roots, yeah, this one's going to be easy. If it is a perfect square, if you recognize it, remember you can always do 3 times 3, that's fine. But we already know this answer. We already know it's plus or a minus of 3. There's no extra tree that had to happen. That looks like it did before. Okay? All right, I'm actually going to skip 6 and 7 just for sake of time. If you need to go back and listen to any of these, they are here for you. Otherwise, go ahead and get started on 8.4's practice.